Welcome back to NurseNet Numeracy, the free-to-use online maths tutorial course designed for nurses. In the previous lesson, we looked at calculating the drip rate if we were given the total volume of solution to be administered over a given period of time, using the formula number of drops per milliliter multiplied by the volume of the fluid divided by time in minutes. But let's look at another type of drip rate calculation you're likely to come across in your nursing practice. A patient requires 200 milligrams of a drug given over a 2-hour period. The drug is suspended in a solution that will be delivered 25 drops per milliliter with a stock dose of 10 milligrams per 20 milliliters. What drip rate should be set? Now, our issue with this question is that we don't know the total volume of the fluid to be administered. And what I mean by that is that looking at our drip rate formula of number of drops per milliliter multiplied by the volume of fluid divided by the time, we are missing the volume of fluid element. But we have been given enough information within the question to help us work this volume out. But we will need to use our basic dosage calculation. Now, we've looked at this calculation in previous lessons, and just as a reminder, you can find this lesson within the Calculating Dose course of the NurseNet website. So thinking back, the basic dose formula is prescribed dose divided by the stock dose multiplied by the volume the stock dose is dissolved in. So looking at our question, our prescribed dose is 200 milligrams, our stock dose is 10 milligrams, and the volume of the solution the stock dose is dissolved in is 20 milliliters. So let's crunch the numbers. 200 milligrams prescribed dose divided by 10 milligrams of stock dose gives us 20. 20 multiplied by the volume the dose is in, which is 20 milliliters, gives us the answer of 400 milliliters. Now we need to work out the time in minutes, so we've been told that the drug should be administered over 2 hours. So 2 multiplied by 60 gives us 120 minutes. Now we're ready to crunch the numbers in our drip rate formula. So number of drops per milliliter is 25, multiplied by the volume of the solution, which is 400, giving us a total of 10,000 milliliters. 10,000 milliliters divided by the time in minutes, which is 120, gives us our drip rate of 83.3 drips per minute, or rounded to the nearest number, it's 83 drips per minute. Okay, let's do another one. A patient requires 300 milligrams of a drug given over a 2-hour, 30-minute period. The drug is suspended in a solution that will be delivered at 35 drops per milliliter with a stock dose of 20 milligrams per 50 milliliters. What drip rate should be set? Well, thinking back to our last example and the methodology we used, let's break this question down into manageable units. Remember, we need 3 bits of information to input into the drip rate formula: the number of drops per milliliter of the drug, the volume of the fluid to be administered, and the time in minutes. In our question, we've been given enough information to input the figures into this formula, but we need to do a bit of work to get the figures we need to make our drip rate calculation formula work. Breaking this question down, we've been told the prescribed dose of 300 milligrams, we've been told the stock dose, which is 20 milligrams, and we've been told the volume of the solution that the stock dose comes in, which is 50 milliliters. So if we do our basic dose calculation, prescribed dose of 300 milligrams divided by the stock dose of 20 milligrams gives us 15 milligrams. 15 multiplied by the volume of the solution the stock dose comes in, which is 50 milliliters, gives us 750 milliliters. Now we have the volume of the fluid element to our drip rate calculation. We also need to convert our time into minutes. So 2 hours and 30 minutes is equal to 2 multiplied by 60 plus 30, which gives us 150 minutes. Now we can input the figures into our drip rate formula. number of drops per milliliter equals 35, multiplied by the volume of the solution, which is 750 milliliters, giving us a total of 26,250 milliliters. We now need to divide the 26,250 milliliters by the time in minutes, which is 150, giving us a drip rate of 175 drips per minute. Okay, it's your turn, but remember the steps we've used to come to the correct calculation, i.e., read the question and identify the measurements we can input into our basic dose formula to give us the volume of the fluid we should administer, and 2, convert the time into minutes. So the question is, a patient requires 400 milligrams of a drug given over a 2-hour period. The drug is suspended in a solution that will be delivered at 35 drops per milliliter with a stock dose of 20 milligrams per 10 milliliters of solution. What drip rate should be set? Give your answer to the nearest whole number. You can pause the video and press play when you're ready to reveal the answer. Okay. At first, we should have identified that we needed to apply our basic dose calculation by dividing the prescribed dose of 400 milligrams by the stock dose of 20 milligrams, and that gives us 20. Now multiply the 20 milligrams by the total volume of the solution the stock dose comes in, which is 10 multiplied by 20, giving us 200 milliliters. That's given us the volume of fluid for our drip rate calculation. Now we need to convert the time into minutes. So 2 hours multiplied by 60 gives us 120 minutes. Now we can crunch the numbers. Number of drops per milliliter, 35, multiplied by the volume of the fluid, which is 200 milliliters, we get 7,000 milliliters. 7,000 milliliters divided by 120 minutes gives us 58.3 drops per minute. Now rounded to the nearest whole number, we get 58 drops per minute. Okay, if you're feeling confident, do the drip rate extended calculation section of the NurseNet numeracy course. Remember, you can find lots more nursing maths help at www.nursenet.uk, or if you're looking for your next career move in nursing, do check out our jobs board. If